So as noted in the last video, we noticed that at our shorter lengths, all of our observed values seem to be above the line, meaning that our line is under predicting the weight based off of a length. And we also noticed this to be true at some of our longer lengths. While in the middle, it looks like it both over and under predicts in a more equal fashion. So this is a concern that maybe our linear model isn't exactly right. And so what we can do is we can think about the residual, which is the vertical distance from our observed value to the line, thinking about how far off from what was actually observed for the weight our line is predicting the weight to be. So we are going to subtract the observed weight for our red drumfish minus the line predicted weight for our red drumfish and look at those residuals and see if there's a pattern to them. Are we always over predicting or under predicting? And we can actually have CODAP do that for us. So we can come over here to our table and we can add a new variable. And we can call this new variable residual, and I'm going to call it red drum. And I'm going to press return. And then I'm going to click on my variable and go to edit formula. And we're going to insert a formula here. It's a statistical formula. And we're going to go to this one that says linear regression residual. This means that from our linear regression line, we want it to calculate for each observation the residual, or that distance from the observed to the predicted weight. So we click on that. And we see that we need to tell it what our X experimental variable is, our Y variable, and then any filters we have used. And so we're going to go here and highlight our X experimental value and I experimental variable, and we are going to insert a value, and our X variable is converted length. I'm going to do the same for Y with converted weight. And then I'm going to go to filter, and we filtered, remember, by species. We're only looking at red drum. So I'm going to insert species, and then I'm going to tell it equals, and we are only looking at, use quotations, red drum. And the reason I capitalized it is because if I look right here, the way it appears in our table is capitalized red drum. And then I'm going to hit apply. And what you notice is in some of the rows, we have a calculated value. And if I make my table a little bit bigger, you can see that all the rows with calculated value are our red drum rows. And so if we think about what one of these values mean, this negative 0.55 here, when we click on it, we can see it shows up on our graph and it's below the line, which is what we would expect because we are subtracting our observed minus what would be predicted by our line for the weight. And so it would be a negative value being below the line. And it means that the line predicts the weight of this fish to be 0.55 more than what we actually observed. Okay. So now that we understand what was calculated, what we want to do for each length is we want to look at a graph where each length, we look at what the residual is for each of those observed values compared to what was predicted by our line. So we're going to press graph. We're going to make it a little bigger. And then we are going to put our converted length on the x-axis. And then we're going to put our residual on the y. And now we are looking at how far away our observed value is minus our predicted for each of our fish in this data set. And what we notice is, as we noted before, the middle values, there's some above and below because there were points on either side, but at our ends, at our shorter lengths and our longer lengths, they are always higher. Our observed values are always higher, meaning that our line is predicting the weight to be lower than what was actually observed. And so what we notice here in this graph is maybe we should have a concern about our linear model, even though we know the R value is really close to 1, meaning that there is a positive correlation. It also suggests that maybe linear isn't exactly the best fit for that positive correlation. And so if you'd like to know more, you can look on the next screen. There will be a link to a CODAP document that will help you think about what models would be better if you'd like to think about models other than linear, like a power model or exponential model. But you can also conclude that while this linear model does a decent job, it's not terrible. We would be very cautious about smaller fish and larger or longer fish when using our model. But we also could say maybe our model is good enough for a fish in the middle. And depending on how much accuracy you need in this model, maybe it's good enough to get you about correct on from predicting weight from length.